Good day, students! Welcome to TV Eskwela, DepEd Davao de Oro. I'm your TV presenter, Teacher Jorgie Almedilla Oliva, from Montevista National High School, Montevista District. Sit down, relax, and have fun. Get your pen, paper, and your Science 9 module. Let us enjoy and have a fantastic learning. Are you ready for today's lesson? That's good! Let us first answer the pre-test on page 1 of your module. Directions. Choose the letter that corresponds to the correct answer. Write a letter of your answer on a separate sheet of paper. Number 1. Which of the following pair of elements would form an ionic bond? I repeat, which of the following pair of elements would form an ionic bond? A. Nitrogen and fluorine. B. Calcium and lithium. C. Magnesium and chlorine. D. Oxygen and oxygen. The correct answer is C. Magnesium and chlorine. Number 2. Which of the following orbital notation illustrates sodium atom? I repeat, which of the following orbital notation illustrates sodium atom? A. 1s with 2 opposite spins. 2s with 2 opposite spins. 2p with 6 opposite spins in all. B. 1s with 2 opposite spins. 2s with 2 opposite spins. 2p with 6 opposite spins. 3s with 2 opposite spins. C. 1s with 2 opposite spins. 2s with 2 opposite spins. 2p with 6 opposite spins. And 3s with downward spin. D. 1s with 2 opposite spins. 2s with 2 opposite spins. 2p with 6 opposite spins. 3s with 2 opposite spins. And 3p with 6 opposite spins. The correct answer is C. 1s with 2 opposite spins, 2s with 2 opposite spins, 2p with 6 opposite spins, and 3s with 1 downward spin. Number 3. Ionic bonds are formed between, I repeat, ionic bonds are formed between A. 2 metals. B. 2 non-metals. C. 2 non-reactive elements. D. Metals and non-metals. The correct answer is D. Metals and non-metals. Number 4. In forming ionic bonds, I repeat, number 4. In forming ionic bonds, A. Electrons are shared by 2 metals. B. Electrons are transferred from non-metals to metals. C. Electrons are accepted by metals from non-metals. D. Electrons are released by metals and accepted by non-metals. The correct answer is D. Electrons are released by metals and accepted by non-metals. Number 5. Reactive metals are mostly found at the... I repeat, reactive metals are mostly found at the A. The right part of the periodic table. B. The left part of the periodic table. C. Middle part of the periodic table. D. Lower part of the periodic table. The correct answer is B. Left part of the periodic table. Before we will start with our new topic, let us have a short review on the previous lesson about electrons and energy level. The fascinating colors of the fireworks are caused by the emission of energy of specific elements. Some metal salts are sodium nitrate with sodium as the element, giving color of the flame yellow, and barium chloride is green. What was the atomic model of Niels Bohr? Excellent! The atomic model of Niels Bohr describes the atom like a solar system, where the electron is found only in specific circular paths or orbits around the nucleus. However, Bohr's model was not sufficient to describe atoms with more than one electron. His idea that electrons are found in definite orbits around the nucleus was rejected. Who are the physicists behind the better model of the atom? Yes, that's correct! The three physicists who led the development of a better model of the atom are Louis de Broglie, Erwin Schrödinger, and Werner Karl Heisenberg. The quantum mechanical model of the atom comes from the mathematical solution to the Schrödinger equation. It describes the atom as having a nucleus at the center around which the electrons moves, and describes a region in space where the electron is most likely to be found. The main energy levels in the atom are numbered 1 to 7 and assigned with letters K to Q. Each energy level has its own corresponding sub-levels, such as S, P, D, or F, and number of orbitals. The maximum number of electrons that can stay in each energy level are, for 1 or K is equal to 2 electrons, 2 or L is equal to 8 electrons, 3 or M is equal to 18 electrons, 4 or N is equal to 32 electrons, 5 or O is equal to 50 electrons, 6 or P is equal to 72 electrons, and 7 or Q is equal to 98 electrons. That is all about electrons and energy levels. Isn't it amazing? Our topic for today is all about formation of an ionic bond and covalent bond. We will start with our first lesson, which is ionic bond. At the end of the module, you will be able to learn and illustrate how an ionic bond is formed using the following approaches. A. The electron configuration. B. the orbital notation. And C, the Lewis electron dot structure. Do you like bonding with your friends, family, or loved ones? Do you miss bonding with your classmates? Bonding as humans are very important in our social and emotional state. Moreover, did you know that the atoms bond as well? That is what we call as chemical bonding. What is chemical bonding? Chemical bonding is the process of linking or joining together of atoms to gain stability and to form a compound or molecule. While chemical bond is a force of attraction that holds atoms together in a compound or a molecule, there are two main types of chemical bond: ionic bond and covalent bond. This time, we will first discuss ionic bond. What is ionic bond? Very good! Ionic bond involves complete transfer of electron from one atom to another atom. It exists between metals and non-metals. Now, for our example, let us consider a very familiar substance, salt. Salt is made up of elements sodium and chlorine. Look at your periodic table if you have one, or open your Science 9 module on page 4. Sodium is a reactive metal found at the left part of the periodic table, and chlorine, a reactive non-metal found at the right part of the periodic table. Do you know what family do the most reactive metals and the most reactive non-metals belong? That's correct! Yes, sodium falls under family 1 or 1A in the old classification, and chlorine in family 17 or 7A in the old classification. When these two reactive atoms combine, salt will be formed, and it is an example of an ionic compound. Before we will discuss the formation of ionic bond between atoms, let us first familiarize some concepts in this lesson. Ionization energy. Energy needed to pull or remove one or more electrons from a neutral atom. Electron affinity. The energy released when an atom takes in an electron. We will also consider the information given on the table below. This will give us some precautionary measure in illustrating the formation of an ionic bond. Family or group 1A or 1 has the covalency number of 1 and oxidation number of positive 1. Family or group 2A or 2 has the covalency number of 2 and oxidation number of positive 2. Family or group 3A or 3 has the covalency number of 3 and oxidation number of positive 3. Family or group 4A or 4 has the covalency number of 4 and oxidation number of positive 4 to negative 4. Family or group 5A or 15 has the covalency number of 3 and oxidation number of negative 3. Family or group number 6A or 16 has the covalency number of 2 or oxidation number of negative 2. Family or group number 8A or 17 as the covalency number of 1 and oxidation number of negative 1. Covalency number refers to how many bonds an atom can have when it forms a compound, while oxidation number refers to the charge of an atom when it loses or gains electrons and becomes an ion. Now, look at your periodic table. What are the elements in family 1 or 1A? Excellent! These are lithium, sodium, rubidium, cesium, and francium. What are the covalency number and charge? Okay, that's right. From the table given, each element has a covalency number of 1, which means they can only have one bond, and an oxidation number of positive 1. Same also with the other group of elements found in the table. How can we account for the charge positive 1? Very good, students! This indicates that each element can give up only one electron. And that explains why sodium has positive 1 charge, while elements in family 17 or 7A can carry a charge of negative 1. What does it mean? Nice answer! This means that the elements of this family can accept one electron. This explains why chlorine carries a charge of negative 1. This explains why chlorine carries a charge of negative 1. Another important table is the electronegativity table. The values in this table will give us an idea of how to determine the type of bond will be formed by the combining atoms. Would it be ionic or covalent? Electronegativity tends to increase from left to right across each period and decreases from top to bottom in each family. Now, let us consider the degree of how the electron is transferred by getting the electronegativity difference. We will use the electronegativity table given. Bond type, ionic bond. The electronegativity value is greater than 1.9. If the difference is less than 1.9, there will be no transfer of electrons, only shared by the combining elements. Consider sodium chloride. The electronegativity value of sodium is equal to 0.9, while chlorine is 3.0. To get the electronegativity difference, you will subtract greater value minus lower value. 3.0 minus 0.9 is equal to 2.1. So, the electronegativity difference is 2.1. And it is greater than 1.9. Therefore, ionic bonding will take place in sodium chloride. The last table is Lewis electron dot structure or LEDs of the different elements. This structure or symbol is composed of the chemical symbol of the element and dots that represent the number of valence electrons. Valence electrons are the number of electrons at the outermost energy level of the atom. The family number is equal to the valence electrons of the element. Are you ready for ionic bonding formation? Bravo! Let's start with a question. How do ionic bonds form between atoms? Consider again salt. the combination of sodium atom from family 1 and chlorine atom from family 17. Kindly watch the video for you to answer the question.
An ionic bond forms when two atoms are held together by the attraction between opposite charges. The reaction between sodium and chlorine atoms is an example of how an ionic bond is formed. Since sodium has only one electron in its third shell, it has a tendency to give up that electron. Once it does, the remaining outer shell contains 8 electrons. This loss of an electron gives sodium a slightly positive charge. Chlorine, on the other hand, tends to gain an electron, since its outer shell already has 7. When chlorine gains an electron, it becomes slightly negative. The charged sodium and chlorine atoms are called ions. Ions of opposite charge attract each other and form ionic bonds. In this case, the attraction of sodium and chlorine form a molecule called sodium chloride, or table salt.
So, how do ionic bonds form between the atoms of sodium and chlorine? Correct! Sodium tends to lose or transfer electron to chlorine, which is capable of gaining electron. So, what is the purpose of losing and gaining electron? Terrific! To attain stability. This time, you will be able to illustrate how ionic bond is formed using first, electronic configuration. What is it? Yes, that's right. Electronic configuration is the way in which electrons are distributed in the different orbitals around the nucleus of an atom. We are going to use Aufbau's principle, which follows the mnemonic and filling up the orbital, like what is found in your periodic table. Example, write the electron configuration of A, sodium. 11 as the atomic number, the electronic configuration is 1s2, 2s2, 2p6, 3s1. In an atom, it looks like this. A. Electronic configuration of sodium and chlorine. Sodium with the atomic number of 11 has the electronic configuration of 1s2, 2s2, 2p6, 3s1. Due to ionic bonding, it loses one electron, and its electronic configuration becomes sodium positive with atomic number of 11, 1s2, 2s2, 2p6. 3s is gone. Chlorine with the atomic number of 17 has the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p5. Due to ionic bonding, it gains one electron from sodium, and its electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6. Combining the two, sodium positive plus chlorine negative will form sodium chloride. Or, crisscrossing the charges, sodium positive with chlorine negative will form sodium with subscript 1, chlorine with subscript 1, or sodium chloride. Note that the charges become subscript and eventually removed because these numbers are the same. The second approach is orbital notation. What is it? Correct! It is a diagram where electrons occupy same orbital, having opposite spin. The orbital notation of sodium is 1s with 2 opposite spins, 2s with 2 opposite spins, 2p with 6 opposite spins, and 3s with upward spin. The orbital notation of chlorine is 1s with 2 opposite spins, 2s with 2 opposite spins, 2p with 6 opposite spins, 3s with 2 opposite spins, and 3p with 6 opposite spins. After ionic bonding, sodium becomes positively charged particle or cation. The orbital notation of sodium positive is 1s with 2 opposite spins, 2s with 2 opposite spins, 2p with 6 opposite spins. Chlorine becomes negatively charged particle or an ion. The orbital notation is 1s with 2 opposite spins, 2s with 2 opposite spins, 2p with 6 opposite spins, 3s with 2 opposite spins, 3p with 6 opposite spins. Note that the single 3s electron of sodium is transferred to chlorine's 3p configuration, making the 3s of sodium to disappear and the 3p of chlorine to be filled. Sodium now carries a positive charge and chlorine a negative charge. Lewis electron dot structure or LEDS is a convention illustrating an atom symbol surrounded by dots which represent the outermost electron or valence electrons. It was developed by Gilbert Newton Lewis. After ionic bonding, take note that sodium loses 1 electron. So, its electronic configuration became sodium positive 1s2, 2s2, 2p6. Which is isoelectronic with neon, having the atomic number of 10, while chlorine having the electronic configuration of chlorine negative 1s2, 2s2, 2p6, 3s2, 3p6, became isoelectronic with argon, having the atomic number of 18. Isoelectronic means sodium attained the same electronic configuration with neon, and in the case of chlorine, it acquired the same electronic configuration with that of argon. Thus, both of them became stable. Do you understand it all, my dear learners? Very good! Let me try to ask you some questions. Number 1. How do ionic bonds form between atoms? I repeat. Number 1. How do ionic bonds form between atoms? That's right! By the transfer of electron from metallic element to non-metallic element. Number 2. Why it is necessary for an atom to lose or gain an electron? I repeat. Number 2. Why it is necessary for an atom to lose or gain an electron? Correct! Gaining or losing electrons is a way of achieving stability. Here, the atom that gained or lost an electron or electrons took the configuration of a noble gas, which is a field configuration, a very stable configuration. Number 3. Why do we have to consider the covalency number and the oxidation number of the atom in the construction of the ionic bond? I repeat, number 3. Why do we have to consider the covalency number and the oxidation number of the atom in the construction of the ionic bond? Good! It is very important to consider the covalency number and the oxidation number of the atom. The covalency number tells how many bonds an atom can form, and the oxidation number tells how many electrons an atom is capable of losing or gaining. In page 10 of your module, do not forget to answer exercises 1A and B, and in page 11, what I have learned and what I can do. Did you understand the lesson I discussed? That's incredible! Congratulations, learners! I think you are ready now to take the assessment test on pages 17 to 18 of your self-learning module. Thank you so much for viewing and listening. Again, I am teacher Jorgie Oliva from Montevista National High School, Montevista District. Saying, dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!